Okay, now it's time to clarify one of the most misunderstood topics in statistics: credible intervals versus confidence intervals. Now, both describe uncertainty, but they come from very different schools of thought. A credible interval is Bayesian, whereas a confidence interval is frequentist. They may sound similar, but they mean very different things. So, a credible interval tells us that there is a 95% probability that the true value lies within the range. Now, this is based on your posterior distribution. You're saying, given my data and my prior, this is the most likely range for the parameter. It's really intuitive, and that's why many people prefer Bayesian intervals in decision-making contexts. Now, let's look at this real quick. So this credible interval graph here shows a posterior distribution for a parameter, theta, which is a symbol commonly used to represent an unknown parameter, and that's what we're trying to estimate based on our data. So this theta or parameter value down here, this is theta, by the way, but this parameter value is the unknown parameter that we're trying to estimate based on data. And the theta here again could be anything you're estimating: a population mean, a proportion, a regression coefficient, a standard deviation, or some other quality of interest. As an example, in estimating average test scores, theta could be the true mean score of the population. So this is modeled as a normal distribution with a mean of 2.5, as you can see with the middle line, the middle red vertical line. And here you can see the key, so it's good to look at just as a reference. And the mean of 2.5 with a standard deviation of 0.5. And then you can see the shaded region represents the 95% credible interval, which ranges approximately from 1.52 to 3.48. Now, this interval contains the most plausible values for theta, given the data and prior beliefs. Now, unlike a frequentist confidence interval, the credible interval allows us to directly state that there is a 95% probability that the true parameter value lies within this range. And this is a core advantage of Bayesian inference. Now, a confidence interval is a bit more abstract. You cannot say there's a 95% chance the true value is in this interval. Instead, you say, if we repeated this experiment many times, 95% of the intervals we calculate would contain the true value. Now, in this view, the true value is fixed. It's the interval that changes from sample to sample. It's a subtle but important difference here. So here we see more of a realistic and data-driven sampling distribution of the sample mean based on 1,000 repeated samples, with each of size 30. And this is from a population with a true mean of 2.5. This histogram displays the distribution of these sample means. And as you can see, the overlaid orange curve here represents a normal approximation. The red line again marks the average of the sample mean, this red line here, which is approximately 2.50. Now the green dashed lines on the outside here indicate the 95% confidence interval, which ranges from about 2.32 to 2.68. Now in a frequentist framework, we interpret this to mean that 95% of similarity constructed intervals, meaning from repeated sampling, would contain the true population mean. So let's compare them directly. The credible interval, we're assigning a probability that it falls in a certain range, whereas the confidence interval, what we're talking about is the method, and the method gives good coverage over repeated trials, but no direct probability for the value itself. So Bayesian intervals are usually more intuitive, and especially when explaining results to others. Now let's compare them side by side. So in Bayesian statistics, a credible interval represents the range within which the parameter, theta, is believed to fall within a certain probability, given the observed data and prior beliefs. For instance, a 95% credible interval means that there is a 95% probability that theta lies within the interval based on the updated beliefs. Now, in contrast, a frequentist confidence interval reflects the reliability of a procedure. So if we were to repeat the sampling process many times, 95% of the constructed confidence interval would contain a true parameter. And this is important. This doesn't assign a probability to the parameter itself, but to the long-run frequency of the method. So the interpretation differs in a very fundamental way. Bayesian intervals express probability about the parameter itself, while the frequency intervals express probability about the interval generating process. So the Bayesian approach really depends on both the data and prior beliefs, and the frequentist approach depends only on data collected in the current sample. In Bayesian analysis, the parameter estimate is fixed, and the interval varies as beliefs and data are updated, as we talked about. But in the frequentist analysis, the parameter is treated as fixed, and the interval varies across repeated samples. So visually, credible intervals are depicted as a shaped region under the posterior distribution, whereas frequentist confidence intervals are often visualized as a part of the sampling distribution of the sample mean. Okay, next we'll apply everything you've learned into decision making. So this is an important part. We want to know how to use this information to make decisions. Now, in the next video, you'll also learn how to use posterior distributions and credible intervals to make informed choices that impact decisions, especially when stakes or risk or uncertainty are involved. Okay, see you then.